Thank you, Fabio. As you can see, I knew it was Fabio who was going to be introducing me, and I didn't trust his introduction at all, so I brought my own. I'm a Python trainer and contractor, so I'm a practitioning trainer. Make sure your trainers actually code so they know what they're talking about. I've been working with Python since 2002, and in 2007 I became a core Python developer, wrote a book called I'm Python in Action, which is a great book and thoroughly obsolete, so I recommend you don't buy it. I'm the original author of unittest.mock, and I maintained unit test in the Python standard library for a while. Now, I'm afraid the talk title is a little out of date. What I'm actually going to talk about is how Python took over the world, because something very special happened this year. Now, I started working with Python in 2002, and the python.org website looked like this. And one of my future slides, we're going to look at the popularity of Python and how it's changed. So when I started with Python, it was about here. And if you go to the TOB index, that's about 1% of all. The back button isn't working, which is a great shame. Somebody who has the computer will have to move the slides back for me, please. Otherwise, we're going to miss out. And what you can see, there's a blue arrow there, and it goes up there. And in 2022, Python became the most widely used programming language in the world. I would really much rather go back with my slide, and it is not doing it. So I will talk anyway. OK, so it was 2002 when I first started using Python, and back then Python 2.2 was the latest version. And I didn't use Python 2.2 for very long. Python 2.3 came out, but Python 2, oh, that's gone back one. Great, let's go back a few more. And there was still Python 1.52 was around, and a few more. Please, great. Let's see if we can get back to the slide with the python.org website. No problem if we can't. Nearly. Yay, thank you. Right, so this is what the python.org website looked like in 2002. This is the web archive, the Wayback Machine, and you can see somewhere there Python 1.5.2. That is a very old Python. And when I started, but there was still a load of web servers running some version of Red Hat, so I had to write code compatible with Python 1.52. OK, and then in 2006, I got my first professional programming job with a firm called Resolver Systems, and we were building a spreadsheet written in IronPython that was going to replace Excel and take over the world. And you can probably tell that it didn't, although we did some really interesting stuff. We built something called Ironclad, which was the first CAPI emulation layer for Python for an alternative version of Python. And we had a version of the Python C API that was fully reference count compatible, fully compatible with all the existing. We had the whole NumPy test suite, I think, running. Now, I'm going to talk about the global interpreter a lot later, and Carl talked about this. IronPython doesn't have a global interpreter lock. But there are two special CAPI function calls to do with the global interpreter lock, PyAcquireGIL and PyReleaseGIL. So we thought we'd experiment with Ironclad. We needed to implement those functions, so we just made them empty stub functions. Carl Meyer talked about the problem of C extensions not being thread safe. We had zero problems because of that particular issue. PyAcquireGIL, PyReleaseGIL, empty stubs. So this is Resolver 1. It's a spreadsheet. You can see there it's a hybrid. The problem was, and I'm going to talk a little bit about spreadsheets, because something that some of you may not have thought about is the most widely used programming interface in the world is the spreadsheet. And this is the formula language. You're probably used to the Excel formula language. It's only expressions, isn't it? You can't have statements or stuff inside. So the most widely used programming language in the world is a pure functional programming language with no side effects, where the order of evaluation is determined at runtime. If you have a cell, A1, and it says equals Z99, you have to evaluate Z99 before you can evaluate A1. So the most popular programming interface in the world is a pure functional programming language with no side effects until you use VBA, where the order of execution is determined by your dependencies within the formulae. Fascinating. We added Python syntax. You can see there's a list comprehension. We added an interactive interpreter. We linearized the cells and compiled the code. What a fantastic project. Defunct. But it's interesting. I find this particularly interesting, the language aspect of it. So what I want to talk next about is what is a programming language. And I think this is actually kind of key to the success of Python, the type of programming language it is. I think, so what's the most fun, we work at a very high level language at Python. What's the most fundamental language of the machine? What is the language the machine speaks? There's two wrong answers I ask for when I teach this. And assembly language is one possible answer, binary is another. Because look at this, binary, patterns of ones and zeros. The computer knows nothing about ones and zeros. It knows nothing about objects. When you're creating Python objects, what actually runs in the code, we saw some of this from Carl, it's machine instructions. This stuff is a human abstraction in order for us to understand. The ones and zeros are a very low-level abstraction. The one corresponds directly to a high voltage on a line or a stored charge, the zero to the absence of a line. So the fundamental language the machine speaks is the electromagnetic dance across wires and etched silicon, choreographed by the beating of the quartz crystal at the heart of the machine. The language the machine speaks is the signal. And the ones and zeros are an abstraction for humans to understand. What programming languages do is they give us a framework to reason about and to visualize the state of the system and the behavior of the system. So this is what programming languages are. Programming languages exist for the convenience of the human, and it's a two-way communication. The computer has deterministic behavior, the deterministic dance. And so we use the programming language to communicate with the computer, but the point is that we're building things. And the programming language gives us tools to understand, to visualize, to make things. And the great power of Python comes in the great freedom it gives you. So a lot of languages, the statically typed languages, the bondage and discipline languages, as we call them very rudely in the Python world, they give you a lot of rules, a lot of constraints. And some people like constraints. Haskell has its followers. And they say Haskell is so complicated to use, by the time you've got it to compile, your code probably is correct. Constraints can help you think. But with Python, you have freedom. And what we do with that is, in order to code well, we use discipline and good habits. So if you're part of the Python community, one of the things you'll learn is people will talk to you about habits, about discipline. They'll say if there's a bad thing that you shouldn't do, the answer in Python is don't do it. But every now and then you might need to. So Python is a general-purpose programming language. This is a lovely quote from Larry Wall, the creator of Perl. Back in 2002, when I started using Python, Perl was our great competitor. We were very worried about Perl. And then when I started at Resolver Systems in 2006 or so, Ruby on Rails was our great competitor. And as we'll see shortly, not so much. So people talk about using the right language for the problem, as if there was some set of problems where C# is the right answer, some set of problems where Java is the right answer, and some set of problems where Python is the right answer. Now, that may well be true, but it's typically not because of the language. It's because of the ecosystem, the infrastructure, the community. And that's where Python wins. So this was an article in 2019. In 2002, Python was a minority language. It was, I started it purely by chance, and it was used primarily by Linux developers. Python is a dynamically typed, interpreted language, and typically that class of languages run much slower than compiled languages. And if we go back a little bit earlier than 2002, we'll see that what happened in the history of computing, there's in particular 4 revolutions that I want to talk about within the computing world. The first one being the agile development revolution, which was going on when I really started development. But the problem was, back in the day, computers were really, really expensive, and humans were cheap. So you picked your development environment to optimize to get the most out of your machines. And if that made life for the engineers pretty hard, well, tough. And then what happened? Computers got really cheap. Computing power went up. I mean, exponentially is always a dodgy word to use, isn't it? Went up a lot. And relative to computers, the computers became much cheaper and the developers became more expensive. And then round about 2007, 2006 or so, we had the web revolution. Google adopted Python as an official language. And people wanted to get stuff to market fast. And the agile revolution was happening. Agile revolution is all about processes, development process, the waterfall process. You plan it all up front, and then you will go away and do it. And the reality of doing it is always hugely different from the planning. So that's a very inefficient model for software development, added to which if you have a 6-month development cycle, your ability to change direction is roughly once every 6 months. The genius of Agile is it breaks development into iterations, 2 weeks. There's lots to it, but this is the biggest takeaway in terms of project management. That doing your planning, your prioritization, business owns prioritization, developers own estimation. That's a powerful guard against developer burnout. And you do your prioritization around your iteration boundaries every 2 weeks. So you can change direction quickly. You are agile. And by 2019, this is where we got. Python is ubiquitous in the financial world. There's a few worlds now where Python is ubiquitous. Machine learning, education, it's a great language for training. Data science is a huge topic, isn't it? Massive, and it's really, that's what the traders are doing. And we got to a point in 2019 where people are announcing to the world, if you don't know Python, you've got no future. So this is the chart from TOB. I gave an earlier version of this talk in 2019, and this is where we were, about the 4th language. 8.5% of all the code worldwide was Python. That was TOB's estimate. 2022, we're at the top. 17% of all code by TOB's estimate is Python. We're the biggest programming language in the world, and that is thanks to the efforts of people like Travis. Hearing him talk about the projects he's worked on that have genuinely changed the world and paved the way for the data science revolution that is happening now. Fantastic stuff. The power of community, the power of passion. People who did these things for the joy of it. This was the thing about Python when I joined. It was a small community. It was pretty slow. So the people who were using it, they did it because they loved it. And they cared about it. And the thing is, everything is better when you care, and Python is better. Okay, so let's look at the, I've talked about the Agile revolution. This is the Google Books Ngram viewers. It only goes up to 2019 because that's their corpus of text. This one isn't that interesting, but you can see the use of the term cloud kind of went up quite a lot, starting around sort of 2008, whenever. Okay, and the cloud essentially comes out of 2 technologies, doesn't it? Virtualization and containerization. And what the cloud did, it's a huge hype, and the consumer cloud is very different from the developer cloud. The developer cloud was a genuine, massive innovation for developers. Because what it meant, they commodified the computer, the operating system, as a unit, as an on-demand unit where we can automate provisioning and deployment. So now we can fully automate. With a few lines of code, I can spin up virtual machines, configure their network, install stuff, run a bunch of tests, and check the results. In a few lines of code. That's a revolution. I can deploy a test system, I can test it, I can create a build artifact, and look, I've got a tested build artifact. Maybe that's the one we can deploy. So containers, commodifying the computer as a unit, led the way to the DevOps revolution. Agile was about the process of software engineering. DevOps is that one I've done next. You see, DevOps didn't really exist until 2012. And when it came about, I was very skeptical. It seemed to me that this is a way the managers are going to try and get me to do system administration, and I don't want to do system administration. It wasn't until I really started working for Canonical on a project called Juju, which is a DevOps development tool. This clock changes every time I look at it. Now it says 20 minutes. It said 9 minutes a few minutes ago. And with Juju, you can describe your system in terms of units of services and components and describe the connections between them. And the genius of this is, what's a programming language? Programming language gives us a framework to visualize and reason about the state of the system. And how do we think about Python objects in a running system? Well, we think about it in terms of our objects and the connections between them. And when we can start to think about our services and the units of our services as objects and the connections between them, it's the same thinking, whole system thinking. And for me, that's the genius of DevOps. We define the processes for development, we define the processes for deployment, and we automate it all. Anything that can be automated should be, because humans make mistakes, and computers, the big problem with computers is they only ever do exactly what you tell them. Okay. And then the next one, and you can see this is coming even later, 2016 starting. And this is machine learning, data science. I've delivered one data science project which involved training other people, so it's not my field, and you're going to hear from other people who know far more about it than me. But my guess is that there's a whole bunch of you here, and it's machine learning, data science, AI is the reason you've come to Python and the reason you're here. And this is a revolution that is happening now, and we're on the edges of it, and it's in the process of changing the world. This is a very much cut-down version of a slide Travis delivered. Number, Conda, PyTorch, TensorFlow. There's a whole ton of stuff we can put in there. Pandas is fantastic. It's an array object. You can load an Excel spreadsheet into it, access it programmatically, and dump it back out. I mean, like in a few lines of code. Amazing. So on the topic of DevOps, there's a couple of books I recommend. This is by Moshe Zadka, an intelligent guy in the Python community. Python is Infrastructure. Very good book. I recommend it. One of the things I really took from it, which is something that I practice, disposable virtual environments. Who's used virtualenv or VMenv? Some of you. Well, and this is where I would have shown you some code, but it's easier not to. So VMenv is a module that comes built into Python, and you can create a virtual environment with it. This is a directory that's mostly a bunch of symlinks to your system Python. But what you can do is you maintain your list of dependencies. I don't think I have a slide of it. If you use pip for your dependency management, you install your dependencies into the virtual environment. You can do pip freeze, which will dump out all of your dependencies with their version. And so long as you keep your requirements.txt in GitHub or in version control, you come to start on this project on a new machine, or someone else comes to start on the project. The first thing they do is they create a virtual environment, pip install -r requirements.txt, and now you've got a localized Python installation with all your dependencies, with the correct version. If you screw it up, you delete it, you blow it away, and you start it again. And this is a fantastic innovation for development. So I'm a great fan of disposable virtual environments. And this book, there's another book here which is just as good. I recommend it because it's got an interview with me in it. And some other fantastic developers. So one of the things that comes out of the community, out of this passion, is a great set of tools. Git and GitHub, of course, are great tools that most developers will be familiar with. Version control, what a fantastic thing. No more emailing around versions of code and hoping you've got the latest version and didn't miss out anyone's changes. You know, we do that with spreadsheets, don't we, until Google Docs, you know. And 10 people change it in incompatible ways, and it's a nightmare. So Git and GitHub, and then you can have a hook on your pull requests, and you can run various automated checks on your code. This is one I recommend at the moment by Łukasz Wanger, who is one of the Python core developers, inspired by GoFMut, which is the tool built into Go, which reformats your code. And Python Black does that. It reformats your code. You can have it any format you want, so long as it's black. And there are a bunch of other tools, PyFlakes, Pep8. This is more reasons why it's worth being part of the Python community in whatever way you can. We have standard practices, good ways of doing things that evolve and change. It's a living thing. And there's a whole set of problems that you can avoid, completely avoid, never suffer from. Dependency hell is a terrible place to be. Do not voluntarily go to hell. And using disposable virtual-ms, maintaining a requirements.txt, knowing what your dependencies are, and if you work in a commercial environment where it's vital that you don't deploy compromised code, keep verified versions of your dependency in version control and have pip install from there, and every time you want to upgrade, verify first, run tests, and then change your versions in requirements.txt. And you can avoid dependency hell. You can avoid multiple incompatible versions of stuff across your machine. The Python community has lots of fantastic tools and good practices to avoid all sorts of problems. I must be getting towards the end of my time. Part of knowing the community, I'm afraid, it's a craft. It means that the only way to learn is by doing it. You have to know Hinek. If you want to know about packaging, read Hinek's blog. Packaging.python.org is the place to go. It's not as bad as Travis said. It's a hell of a lot better than it used to be. And I can't really talk about community without talking about the times the community gets it wrong. And my favorite example for this is the syntax for decorators. The @ symbol for decorators. There was a huge flame war, hundreds of emails. Essentially, nobody but Guido liked the pi syntax, the @ syntax. And it turned out that he was right and all the rest of the world was wrong. We love it. So the community isn't always right, and Python isn't perfect. And one of the places where it's very much not perfect is the global interpreter lock, which we've heard a little bit about. You can run multiple threads concurrently within Python, so long as only one of them is in the interpreter loop that Carl showed us in the py_eval_frame function. Only one thread of code at the global interpreter lock. And in a world of multi-core, and multi-core compatible concurrent languages like Go, this is an issue. So there are various people attempting to solve this problem. This was a very big one, work by Larry Hastings, and he successfully completed it. He removed the GIL, he put all the locks in place, and it's a particular problem because of reference counting. Touching an object changes it, just like in the real world. The observer changes things. So it's a hard problem to solve. And what Larry proved was that in the presence of reference counting, removing the GIL slows Python down unacceptably. And this is the project that Carl mentioned. Python no GIL, targeting Python 3.9 now. Carl tells me that might not be true. I was reading from their document. He says it's about a wash on performance. But you can try it out. It's fantastic. The trouble is it's a very complex change. They changed the memory allocator. So whether or not this code makes it back into CPython, we don't know. But there are lots of attempts at this. Another one is PEP554, multiple interpreters, sub-interpreters, each with their own global interpreter lock running in a separate thread. That's Eric Snow has been working on that. And that's actually the approach that we used in IronPython. We had a Python engine, and we had multiple code executing multiple Python engines. So I really like that approach, and I hope it works out. And that is my talk.
Perfectly on time. So, questions? And sorry, thank you, Michael. This was an excellent talk. Probably the most dramatic, engaging talk you will see. But thank you so much. Questions?
It seems I have a lot of them here. I've shown up at the right place. So thank you for the wonderful talk. Just want a quick opinion on poetry, if you've used it and your opinion of it.
I haven't used it. So Hinek wrote a fantastic blog outlining, and it's 2018 or something, it was a while ago, and it included poetry, pipenv, and a huge amount of the tools. And reading through it, his opinions and summaries and the drawbacks, I remained convinced that my approach with disposable environments and requirements.txt solved all the problems I had, and there was zero advantage to be gained from using more complex tools. So that was my opinion, for the situations that I've faced. Other situations may be different.
Not as a counter question, but like I'd mentioned initially. Yeah, that was going to happen eventually.
Yeah,
I saw you come to the edge a few times. Yeah.
You have to live on the edge. And it's fine so long as you're willing to jump.
Yeah, so, you're a very experienced programmer, and I'm getting there. But my opinion is also the same, that I did try using poetry, but I think pip solves everything so far.
Thank you. Thank you for your question. Any other questions? Question on the back on the left side. Thank you.
I've noticed a trend of DevOps and Agile having a bit of a backlash lately. I don't know your opinion. Is something happening? Is there a real problem?
So Agile changed the world of development, and the most noticeable way it did was the creators of Scrum stole the idea of iterations, and they stole the open source terminology for sprints. And Scrum works very well alongside Waterfall. I worked for a very large American corporation developing a product, and half the developers thought they were Agile because they were doing Scrum, and they had the worst Waterfall. I worked there for a year. They had the worst Waterfall development process I'd ever seen. Like, huge death march to get the release out, by which time half your developers are burning out, so you have to spend 3 to 4 weeks planning to give everyone a break, and the reality of development throws all that planning away within about 2 or 3 weeks. But you need to do that also because you've got huge layers of managers who all need to feel like they're doing something useful and putting their input in. So it has changed the world. There is a huge there's a backlash. Anytime you tell anyone to do something, they'll react. You know, people love to have opinions. There's a lot of deep wisdom within Agile. Test first. I don't do test first all the time now, test-driven development. But what we applied this rigorously, religiously, pair programming, 4 years. And what test first? You write the test before you write the code. So the first thing you have to think about is what's the API going to be? How would I like this to be? What's the best way? And you design the API instead of just living with whatever you come up with, which is what most people do. Bang out the code, write a few tests, live with whatever you built. Test first puts design thinking and testability right before, and it's a good habit to get into. It changed how I develop, even though I don't always do test first now. So there's such a lot of wisdom in DevOps as well. I mean, I like to talk about process engineering. I haven't done a talk about this yet, but Agile is all about development processes, making development processes human. This stop everything every 6 months and spend 3 weeks planning and then go away and work and do it all. Agile is a much more rhythmic process. It's much more fits with how humans work. And we can, with DevOps, we automate deployment, we automate provisioning, we automate testing. We have processes for all of these. So you can make your whole development, engineering, deployment into a set of processes that you understand, that are automated, that you can teach people. There's a lot of wisdom in these things.
Thank you. Any last question? Great. Thank you, Michael, so much. It was an excellent talk.